Okay, this is the pre-cal lecture video for section 3.8. So if you'll get your 3.8 notes out, we'll go through those. So this entire section is about inverse functions. So an inverse function undoes another function. An inverse function reverses the original function's input and output values. If g of x is the inverse of f of x, then g of f of x is equal to x, and f of g of x is equal to x. I'll show you what that means in a minute. But our first example, let's say we've got a couple of functions. F of x is equal to 2x minus 3, and its inverse is g of x, and that's equal to x plus 3 over 2. Okay, so if these functions are inverses, so let's say f of 1, we'll plug 1 in, that'd be 2 minus 3, that's negative 1. If these functions are inverses, which they are, if you plug negative 1, the output into g of x, then that'd be negative 1 plus 3, which is 2 over 2, that's 1. And see how the output of g of x matches the input of f of x. So that's what happens with inverses. Let's do another. Let's use f of 3. F of 3 would be 2 times 3, which is 6 minus 3, so that's just 3. If we were to plug that into g and get g of 3, that's going to be 6 over 2, which is also 3. So the output matches the input there. And then a third example, let's try a negative 7. 2 times negative 7 would be not negative 7. I just gave the game away. All right, let's say negative 2. 2 times negative 2 is negative 4 minus 3 is negative 7. Oh, now you see where that came from. Let's plug that into g. Negative 7 plus 3 is negative 4 divided by 2 would be negative 2. So the input and output values reverse. Okay, pause the video if you need to. The next example is, does f of x equal x squared have an inverse? Okay, so let's say if f of x is equal to x squared, a good guess for the inverse would be square root of x, right? That'd be a good guess. Okay, so let's see if that works. So f of 2 is equal to 4, right? And then we would plug that into g, and we would expect to get 2. And we do. But let's try another one. Let's try f of negative 2. Well, negative 2 squared is going to be 4. And then let's plug that into g. If you do that, you will get 2. Wait, excuse me. 2. Which does not equal negative 2. Okay, so since 2 doesn't equal to negative 2, they are not inverses. Okay, so not all functions have inverses. And inverse notation, okay, f of x, one way that you can write that something is an inverse, all right, the inverse of f of x is f, and you put a minus 1 of x. I know that is a duplication of symbols in math, because if you have x to the minus 1, that's 1 over x, right? You just have to know that if it's with a function, f to the minus 1, that means it's an inverse, okay? So it's not the same as this. Okay, let's turn to the next page. So we're going to have the horizontal line test. And you see you're going to be drawing graphs on this page. So if the graph of a function intersects every horizontal line at most once, then the function has an inverse. A one-to-one function satisfies the horizontal line test. Every x maps to one y value, and every y maps to one x value. All right, so let's draw these graphs. Okay, the first one. All right, let's say you just have a nice line like that, y equals f of x. So does that pass the horizontal line test? Well, yes, it does. Horizontal line pierces that line only one time, so it passes. So it does have an inverse. All right, the next example underneath that, let's draw a parabola looking like something like that, a big U. Now, does that pass the horizontal line test? Nope. All right, it pierces it in two places. So it fails. So this function doesn't have an inverse. All right, and then the last one on the bottom, you're going to do two graphs side by side. Let's say something like that. Wow. Something like a cube function. Does that pass? Yeah, it passes. It doesn't pierce in more than one place, so passes. HLT. So it does has an inverse. I think I just used bad grammar by accident. All right, and then the one next to that. Still one. Okay, does that pass or fail? That's like a, like a cosine wave or sine wave. You'll learn about that. All right, that fails. So no inverse. Okay, let's move on to page 3 of your notes. Give you a second to pause the video. All right, identifying inverse functions graphically. So we're 3.8.3. So here you're going to be drawing a lot more, or you're going to be drawing a couple more graphs. I know that just makes you so happy. All right, so A, B. Okay, so what an inverse does is it is a reflection point across the y equals x axis. So that's just a line with a slope of 1. Okay, so if I were to put a point at BA, and let's say you were to take that point and you would put paint on it, okay, and then fold it over across this y equals x line. Let's say there's a piece of paper and you were able to fold it across that line. Where the paint hits on the other side is the inverse point. So that would hit about right here, especially if I had drawn this better. All right, maybe you'll do a better job than me. So that's at the point A, B. Okay, so again, it's just a reflection across the y equals x axis. All right, I'm going to erase this. So our next example, let's say we have f of x is equal to 2x minus 3, and the inverse is equal to x plus 3 over 2. And let's do our line that y equals x. Okay, 2x minus 3 is a line that has a y-intercept of negative 3, right? Okay, so let's put that about right there. And a slope of 2. Okay, so let's see, 1, 2, 3, 4. So slope of 2 would be up 2 over 1. So if I were to connect that, that's y equals 2x minus 3. That'd be that line. So if you were to fold, if you were to put paint on that and fold that paper across the y equals x axis, where would it land on the other side? Well, it would give you the inverse, x plus 3 over 2. X plus 3 over 2 has a slope of a half and a y-intercept of 3 over 2. Okay, so its y-intercept would be 1.5. It's about right there. And the slope is 1/2. So the inverse line looks kind of like that. So that is y is equal to x plus 3 over 2. So again, if you were to take this original line, put paint on it, then fold the paper across this y equals x axis, where would it make a mark? It would make a mark on the inverse and give you an inverse line that looks something like that. All right, I know some of you are still drawing, so go ahead and pause the video and I will move on. All right, you can identify inverses algebraically. So the question is, are f of x equals 2 over x plus 6 and g of x equals 6x plus 2 over x, are those inverses? What you have to do is find f of g of x. Does it equal to x? All right, is that true? Okay, well, here's how you find f of g of x. You plug g of x, 6x plus 2 over x, into the x down here. Wherever there's an x, plug in 6x plus 2 over x. See how that's g of x? And I'm plugging that in right there. All right, so plus 6. Don't forget about the plus 6 there. And can you reduce this into x? Okay. So let's see. That's going to be 2 over 6x plus 2 over x plus 6x over x. I just got a common denominator, multiply that by x over x. That's going to be 2 over 12x plus 2 over x. And that does not equal x. You can monkey with that all you want, but it's not going to reduce down to x. Okay? So if one of them doesn't work, then you don't have to check g of f of x. G of f of x on an inverse also has to equal x. But this one didn't work, so we don't have to check the other one. So they are not inverses. Okay? Let's try another one. we want to determine f of x equals 2x plus 5 over 3, and g of x is equal to 3x minus 5 over 2. Are those inverses? Well, if they are, f of g of x is, you plug g of x into x, and it will reduce down to x. So that's going to be 2 times 3x minus 5 over 2. So I just plug that in for x, plus 5 over 3. Well, the 2's cancel, and you have 3x minus 5 plus 5 on top over 3. And that's going to, 5 and negative 5 cancel, so you'd have 3x over x, 3x over 3, and that's just x. So that one worked. Let's try the other one. That's f of g of x. How about g of f of x? They both have to work for them to be inverses. So g of f of x, we're going to plug f of x into that x right there. So that's going to be 3 times 2x plus 5 over 3 minus 5 over 2. All right, the 3's will cancel, and you have 2x plus 5 minus 5 over 2. And that's going to be 2x over 2. So that cancels out, and that's x. So the answer is yes, they are inverses. Okay, turn over to page 4 of your notes. Going to do a couple more graphs. Just going to graph some inverses here. So you've got two graphs, one on top of each other. The first one, so instead of lines, let's do a curve. So we have the line y equals x. Okay, so let's say we have a curve that looks like this. All right, what would the inverse look like? Well, it would look something like that. Okay, so if you were to, if this is f of x, and this one down here would be the inverse. If you were to put paint on f of x and fold it across that line, that dash line, that's what the inverse would look like. Let's draw another one. Okay, let's draw one that looks kind of like the cubic function. All right, so we'll have something like that. All right, I forgot to draw my y equals x line, so let's stick that in there. All right, let's say this is f of x. The inverse this is going to be the inverse. Okay, so the original one would be this, and then if you fold it across the line y equals x, the inverse would look something like that. So that's just a couple of examples with curves on what the inverses look like. All right, pause the video if you need to. And no more drawing on this lecture. Okay, 3.8.6 is finding inverses algebraically. So our procedure: swap the x and y variables, solve the new equation for y, All right, if it's a one-to-one function, okay, so it doesn't have more than one solution, doesn't have a plus or minus, then you found the inverse. All right, so our first example is find the inverse of y is equal to 4x minus 3. Okay, so we're going to swap the x and y. So x is equal to 4y minus 3. And now we're going to solve for y. So we'd have x plus 3 is equal to 4y. X plus 3 over 4 is equal to y. That is a one-to-one function. There's no plus or minus out front. And so that's your inverse. All right. And the way you can write that is f to the minus 1 of x. So we don't have to put y. Next example is y is equal to minus 6 over x. So we're going to swap the x and y. X is equal to minus 6 over y. Right, and then swap, and then solving for y is minus 6 over x. So that's a one-to-one function, no plus or minus. Sometimes the inverse is itself. All right, so that's f to the minus 1 of x. All right, if you want to see what that looks like, try graphing it on your calculator. All right. Next example. Towards the end, y is equal to x squared. Okay, let's swap the x and the y. So we'd have x is equal to y squared. So I just took y and made it x, took the x and made it y. And now we're going to solve for y. All right, so the square root of x is equal to y, but it's plus or minus. So this is not 1, 2, 1. So there's no inverse. Well, you know what? You know what that looks like. It's a parabola. Does a parabola pass the horizontal line test? No. So you know it doesn't have an inverse just by eyeballing it. All right, I think I can fit the next one on here. Y is equal to, excuse me, sorry about that. Oh no, I had it. X is equal to, excuse me, y is equal to x to the 4th. Swap the x and the y. X is equal to y to the 4th. And then solve for y. So the 4th root of x is equal to y. But anytime it's an even exponent, you're going to have a plus or minus when you take a root. Okay, so this is not one-to-one. So no inverse. Okay, let's do one more example and we'll be done. So we have y is equal to x cubed minus 7. Swap the x and y. X is equal to y cubed minus 7. Move that negative 7 over to the other side. X plus 7 is equal to y cubed. Then the cube root of x plus 7 is equal to y. If it's a odd number, all right, like the cube root, if it's an odd number, then it won't be plus or minus. They can be positive or negative there. So it won't be plus or minus, so that is the inverse. That completes the lectures for Chapter 3. So work on your homework. I will give you the homework solution video after the homework is due. Check MS Teams for due dates. I'll talk to you next video.